6.1 quick review, exercise 1 through 10. Section 6.1 our book has to do with vectors, and so this quick review is a preliminary to working with vectors. And so we're going to go over the odd number problems 1, 3, 5, 7, 9. In exercises 1 through 4, find the values of x and y. Well, the equations we need that are going to be most helpful for this are these. R cosine theta equals x, and R sine theta equals y. And R means radius, so if you kind of think that you've got a circle, in this case with a radius of 9, well, we can find the x value by multiplying the cosine, the radius, in this case the hypotenuse, times the cosine of theta, which is 30 degrees. And let's go ahead and put this in our calculator. We have R, which is 9, times cosine of 30 degrees. We got to make sure our calculator is in degrees, which I already have done. We get approximately 7.794. So we go here, we'll put x approximately 7.794. And that's going to be our x value. Now our y value, r sine theta equals y. Well, the sine of 30 degrees equals 1/2. And that has to do with the 30, 60, 90 right triangle. You have the long side is what we call 2x, and the short side, in this case, which is the opposite of 30 degree, is x. So 1/2 of this 2x side, that's going to be this side here. So y is going to be equal to 9 times 1/2, which equals 4.5. So that equals y. Now notice I have x is approximately equal to 7.794, but y is exactly equal to 4.5. Next on our problem, 3, we have the same thing here. R cosine theta equals x, and R sine theta equals y. In this case, we can use a reference triangle. I'm going to briefly demonstrate that, but we can just straight up use this 220 degrees. And so we have, let me see what that is, 7, right? So we have 7 times cosine of 220 degrees. We get negative 5.362. So we go here, x approximately equal to negative 5.362. And y is going to be 7 times the sine of 220 degrees. And we get negative 4.4995, so that's going to be negative 4.500. So y is approximately equal to negative 4.500. And we can also do this problem using a reference triangle. And a reference angle is going to be found by dropping straight to the x-axis, in this case straight up. And what we have for this angle here is going to be this 220 minus 180 degrees. So our reference angle is going to be 40 degrees. And so we can also find our x and y values by taking the, we'll say, negative 7 times the cosine of 40 degrees, and why negative? Because we're going down in the third quadrant, and that's going to be x, and our y value is going to be negative 7 times the sine of 40 degrees, and that'll be equal to y. So that's using a reference angle. But the thing about using a reference angle is you have to actually consciously put that negative sign out in front to end up getting the right answers for the x and y value. Whereas in a standard position angle, okay, this angle here is in the standard position all the way here to our hypotenuse equals 7. So anyway, that's problem number 3. Next on our problem, which is 5, we have theta equals sine negative 1 of 3 over square root of 29. Well, this is what this negative 1, it's not okay, sine to the negative 1 is not sine to the power of negative 1. So, what that does, that's an inverse. And so we go to take an inverse, we go to our calculator and put in sine, and put in trig, sine negative 1 of, get a fraction, and I think that's 3 over square root of 29. Make sure that's right. Yeah, that's right. And we get an angle value, which is going to be an angle of 33.85 degrees, we'll call it. So 33.85 degrees. Just a straight up calculator problem. Next odd number problem. Exercises 7 through 9, the point P is on the terminal side of the angle theta. Find the measure of theta if theta is between 0 and 360 degrees. So in this case, we have the point 5, 9, so let's go ahead and construct an x and y axis. So we have x and y, and we go to the right 5 units, 3, 4, 5, and up 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so right here is where our point is at 5, 9. So I'll put in 5, 9. And our reference angle is going to be this. Okay, we drop straight to the x-axis. It's this blue line segment straight to the x-axis. And then we put our diagonal straight up here. So our theta is going to be right here. And what we have is this opposite side of theta is 9, and the adjacent side here is 5. So we can say the tangent of theta equals opposite over adjacent, or 9 over 5. And so to find the theta by itself, if we take the inverse tangent of this equation, taking the inverse tangent of tangent theta, we get theta, and taking the inverse tangent of the right side, we write as tangent negative 1 of 9/5. And so now we can just go to a calculator, okay, and we will put Okay, tangent -1 of 9/5. So we go here, tangent -1 of 9/5. And for that we get 60.945 degrees. So going back here, we get 60.945 degrees. And that's going to be the measure of theta. Now, in problems 8 and 9, we go to a different portion of the coordinate plane. So problem 9, we do the same thing. We draw an x and y coordinate plane. Put x here, y here, and -2. So that's x is -2, and y is -1, 2, 3, 4, 5. And so we have down here in quadrant 3, -2, comma, -5. Now, what we're going to need to do is get a reference angle, and to do that, we go straight up, in this case, from the point 2, comma 5 to the x-axis, and then we know that we also draw straight from the origin. Okay, so that's straight to the origin. And then our adjacent side is up here, the x value, which is -2, and the y value, the opposite, is -5. And we take the tangent, and we'll put the theta sign right here. We are going to find an angle. Now it's going to be inverse tangent of -5 over -2, but then to that, we are going to have to add another what? We're going to have to add another 180 degrees. Because 180 degrees takes us from here in the x-axis all the way around 180 degrees to the other side. 180 degrees is the number of degrees in a line. And so we'll say that theta is equal to inverse tangent of -5 over -2. Now you know that's going to simplify to 5 over 2 plus 180 degrees. So theta is going to be found by making this calculation. So we go to the inverse tangent right here. Inverse tangent of, I'll just put 5 over 2. That's the same as -5 over -2. And to this, we're going to add the 180 degrees. And we get 248.199 degrees. 248.199 degrees. Okay, so that's going to be our answer to problem number 9. Now, problem 8, at 5, comma, -7, you're going to be in quadrant 4. And so you're going to get a negative angle for an answer. So to that, you're going to have to add 360 to get your angle between 0 and 360 degrees, like we did for problem 7 and 9. Now, I'm not going to directly do problem 10 completely, but just kind of explain what's happening. We have bearings. Now, these are probably azimuth bearings, but we're going to pretend like we're on a coordinate plane. And to do that, I'm just going to make a sketch like this. Okay, so what that says is if we're traveling for 3 hours at a bearing of 42 degrees, that means, and at knots, we're going to be going at, okay, this is going to be 42 degrees right here. And it's going to be, the distance is going to be 3 times, at 3 hours, times 42 knots, which is sort of nautical miles per hour. So that's the distance. Okay, and so you're going to get an x value by taking 3 times 42 times the cosine of 42 degrees, and then the y value you're going to get by taking 3 times 42 times the sine of 42 degrees, and then 5 hours on a course of 125 degrees. And so here's going to be about 125 degrees out this direction, but this one is going to be at 5 times 42 knots, because we're saying 42 knots, right? So a greater distance, and this angle here is going to be 125 degrees. Well, again, you're going to have to take 5 times 42 times the cosine of 125 degrees to get your x component, and 5 times 42 times the sine of 125 degrees to get your y component. So you're going to be up here somewhere between the final distance, and then you'll get the final bearing and distance, and you'll get the bearing by taking the inverse tangent, and you'll get the distance by using the Pythagoras x. Anyway, the x value and the y value. So that's just a little hint on problem 10. Anyway, good luck on your even number problems from this set, and thanks for viewing.